All right, in this video, we're going to talk about supplemental examples from 8.5, where we did partial fraction decomposition. Let's go ahead and look at this first example. Remember to always try your U substitution first. That's not going to work, or it does not work nicely. So we're going to try and factor the denominator here. X plus 2 times x minus 3. 2 times a negative 3 is a negative 6. 2 plus a negative 3 is a negative 1. Have a 1 dx up there. So we're going to split this into something over x plus 2 dx plus a different something over x minus 3 dx. So a times x minus 3 plus b times x plus 2 needs to be equal to 1. And because I have distinct linear factors, I'm going to let x equal negative 2 and make this negative 5a equals to 1. And a is equal to a negative 1/5. And then let x be equal to 3. And 5b is equal to 1, and b is equal to 1/5. That only works with distinct linear factors. And so this is going to be integral of dx over x plus 2 times x minus 3 is equal to negative 1/5 integral of dx over x plus 2 plus 1/5 integral of dx over x minus 3 is, this is negative 1/5 ln of the absolute value of x plus 2 plus 1/5 ln of the absolute value of x minus 3 plus c. All right. Taking this example from the notes as well, find the integral of x squared minus 9x plus 50 over x cubed minus 10x squared plus 25x. Try the U substitution first. X cubed minus 10x squared plus 25x. And I take the derivative. We get 3x squared minus 20x plus 25. And that doesn't appear to have a nice U substitution here. So when we factor the denominator here, factor out your common factor of x, leaving you with x squared minus 10x plus 25 is going to be x times x minus 5 squared. And we have a repeated linear factor. So this is going to break down into x plus 50 dx over x times x minus 5 squared is a over x dx plus b over x minus 5 dx plus c over x minus 5 squared dx, like that. I think I used a1, a2, and a3 in the notes, but so be it. The integral of x squared minus 9x plus 50 dx, x times x minus 5 squared is equal to a times x minus 5 squared plus bx times x minus 5 plus cx x times x minus 5 squared. So a times x minus 5 squared plus bx times x minus 5 plus c x needs to be equal to x squared minus 9x plus 50. And let's use a similar trick to above. I'm just going to have to use an extra number here, but let's let x equal to 5. And when x equals to 5, this is 0 and this is 0, and I have 5c is equal to 25 minus 45 plus 50. So that's 5 and 25 is 30. C is 6. If C is 6, then I can say that this is for sure a times x minus 5 squared plus bx times x minus 5 plus 6x. Take that over to that side. For x squared minus 15x plus 50, like that. And now I have let x be 0 and 25a is equal to 50 and a is equal to 2. And then I'm going to let x be equal to, let's see, a is 2. So when I let, let's not pick, let's just pick another number, like let x be equal to 1 now. And I get negative 4 squared is 16a. And then b times negative 4 is negative 4b. 1 minus 15 is negative 14 plus 50. 50 minus 14 is 36. And I know that a is 2, so 32 minus 4b is 36. So negative 4b is 4, and b is negative 1. So again, could have used the calculator for all of that. And if I did, let's just show you how I would have done that. And that would have saved me a lot of work here. Because I used the calculator in the notes quite a bit. I'll get the same answer here. So if I set up a matrix here, after expanding everything, it's going to look like this. A plus b x squared plus negative 10a minus 5b plus cx plus 25a is equal to x squared minus 9x plus 50. And so a plus b has to be equal to 1. And negative 10a minus 5b plus c is equal to negative 1. And 25a is equal to 50. And we're going to set up our matrix here that looks like this. 1, 1, 0, 1, negative 10, negative 5, negative 1, 25, 0, 0. This is negative 1. This is 50. And we're going to RREF, reduced row echelon form that. And we get 1, 0, 0, 0, 1, 0, 0, 0, 1. My answers here are 2, -1, and 6. So that tells me that I have 2 integral of 1 over x dx minus integral of 1 over x minus 5 dx plus 6 integral of 1 over x minus 5 squared dx. This is 2 ln of the absolute value of x minus ln of the absolute value of x minus 5 minus 6 over x minus 5 plus c. My u was x minus 5, dx was du, n was a -2. -2 plus 1 is a -1. When I divide by -1, that's the same thing. It's multiplying by -1 out here. So that's my final answer. This is a textbook problem here from section 8.5. Let's use substitution and partial fractions to find the indefinite integral for integral of 5 cosine of x dx. And we have a denominator of sine squared x plus 3 sine x minus 4. So let's see what this denominator factors into. Bet that u is equal to sine x here, and du is cosine of x dx. So this is 5u over u squared plus 3u minus 4 is 5u over, so I don't even need really to do partial fractions, but I will because the instructions told me to. 5u over u plus 4 times u minus 1. Sorry, this is 5 du, not 5u. 5 du. There we go. And let's just leave that 5 in the numerator. It's going to help us to not have to remember it being outside. So this is going to break down into integral of something over u plus 4 du plus something over u minus 1 du, like that. And a times u minus 1 plus b times u plus 4 is equal to 5. So let u equal a -4 to start off with. That's a -5a is equal to 5, and a is a -1. Then let u be equal to 1, and 5b is equal to 5, and b is equal to 1. So this is negative du over u plus 4 plus du over u minus 1 is a negative ln of u plus 4 plus ln of u minus 1 plus c, where u was equal to sine. So negative ln of the integral of the absolute value of sine x plus 4 plus ln of the absolute value of sine x minus 1 plus c. And that's the same thing as ln of sine x minus 1 over sine x plus 4 plus c. Right. I think this is our last problem for this section. Use partial fractions to evaluate the definite integral, the integral from 1 to 2 of x plus 1 over x times x squared plus 1 dx. And I don't have a nice u substitution here because degree of the bottom is 3 and degree of the top is 1. So let's go ahead and look at this where I have, this is going to have to break down into a over x plus bx plus c over x squared plus 1 dx. So a times x squared plus 1 plus bx plus c times x needs to be equal to x plus 1. So ax squared plus a plus bx squared plus cx is equal to 0x squared plus 1x plus 1. So a plus b, my x squared part's equal to 0. And c is equal to 1. And a, my only constant term here, is also equal to 1. So that means 1 plus b is equal to 0. So b is a negative 1. So that makes this 1 to 2 of a is 1 over x dx plus 1 to 2. And b is a negative 1. It's a negative x plus, and c is 1 over x squared plus 1 dx. So this is the easy part, ln of absolute value of x from 1 to 2. And then I need to split this up here. 1 to 2 of negative x over x squared plus 1 dx plus 1 to 2, 1 over x squared plus 1 dx, like that. And this out front like that. And then this is 2 and 1/2 to make a u du substitution. This is ln of 2 minus ln of 1 minus 1/2 of ln of x squared plus 1 from 1 to 2 plus arctangent of x evaluated from 1 to 2. So ln of 1 is 0, so this is ln of 2 minus 1/2 ln of 5 plus 1/2 ln of 2 plus arctangent of 2 minus arctangent of 1. So 3/2 ln of 2 minus 1/2 ln of 5. And then arctangent of 2, I don't know what that is. I'll leave that just as is. But I know what arctangent of 1 is, and that's pi over 4. So there's my final answer. And we'll come back next time and talk about some supplemental examples from 8.8. See you for the next video.